secant of x equals 28 over 13. It's in quadrant 1, and that's very important. So which quadrant it's in makes a difference. Find the tangent of 2x. And so I'm going to need you guys to look at a couple of things. One, remind yourself what secant is, okay? And two, what is the identity for tangent of 2x? And that's on the resources that I've provided you, okay? So you may have to look it up, but those are two pieces of important information. Secant, so the secant of x is equal to 28 over 13. And it's in quadrant 1, which matters. And they want us to find the tangent of 2x. And the first problem we have here is you cannot go straight from here to here, because one of them is just x and the other one is 2 times x. And the way trig functions work, you cannot directly correlate those two angles together unless you use an identity. You have to know what the relationship is. So we need to rewrite tangent of 2x using some other expression. And so do you guys have the identity for tangent of 2x there? And that sounds exactly right. So there's the identity that tells us what tangent of 2x is. Now we have angles that match. So we have an x here, and we have only x's over here as our inputs to the functions. And that's very important. You have to have the same inputs to your trig functions before you start the next step. And the next step then is to actually think about what this means. So if I have secant of x, well, let's remind ourselves, secant of x in terms of a triangle. So if I drew a triangle, I'd have r, x, and y. It's r over x. Okay, so secant of x is r over x. That's a freaky looking r. Okay, and so then I can use that information now. I know that r is 28 and x is 13. I could either use the Pythagorean theorem, or if I have a good memory, I could remember that r is always equal to the square root of x squared plus y squared, and then rearrange that. But it's probably easier for most people just to use the Pythagorean theorem. So if I go up here and look, I know that x squared plus y squared would equal what? R squared. So there's the Pythagorean theorem. I'll plug in what I know. And I should point out, this angle x, is it the same x as here? No. And so I should actually, I'm going to emphasize that. This is not angle x. And that is going to really confuse people, because when they use the variable x for an angle, that really messes with people. Because we're used to thinking of x as a distance on the coordinate plane. But you really, this is like a theta right here. Okay, it's an angle. Whereas when I write x over here, I'm not talking about angle x, I'm talking about distance x. Okay, so all of these x's are the distance x, not the angle x. Okay, and it's important to be able to recognize the difference. So the angles will always be inputs to a trig function, okay, or outputs from an inverse trig function. But we can solve now and find y. So if we plug in our information, I know that x was 13. I don't know what y squared is. R is 28. And then y squared would equal 28 squared minus 13 squared. So y squared is, and I can go to a handy dandy calculator. So this is 615 right here. And so y equals square root of 615. Okay, so 615, and let's see, is there any nice perfect squares that go into 615? I don't think so. So that's going to be an ugly one. I know then that the tangent of x, okay, and this time I am going to come over here and change this, oops, to yellow because, okay, so remember now we're talking about the angle x, and that is going to equal whatever y over x is over here. So the opposite side over the adjacent side, which we found out the opposite side is root 615, and the adjacent side is 13. Okay, and so that's tangent. Now I can calculate tangent of 2x using this formula. So tangent of 2x, and this is not angle, or this is not x, the adjacent side, this is x, the angle, is equal to, and now we're going to go and calculate these out. So 2 times tangent of x, which tangent of x is this, and then 1 minus tangent squared of x. Well, this is actually going to work out pretty nicely because it will get rid of that square root. Okay, and so then simplifying that, it's going to be 2 root 615 over 13, all divided by, and when I square this, what's 13 squared? 169. So I'm going to write number 1 there as 169 over 169, so that when I square this, I can find a common denominator quickly and easily. And so that would be 615 over 169. And so now we have 2 root 615 over 13, and 169 minus 615. So it's going to be negative 4. All right, that sounds right. Okay, and so then this part I can copy dot flip. All right. Benefit of using digital. Okay, so then we've got, we'll use copy dot flip. So 2 root 615 over 13 times negative 169 over 446. 2 reduces with 446. 13 reduces with 169. And so 13 root 615 over 223 would be the exact answer. But I think this problem, if I remember correctly, it asked us for an approximation, correct? It said give your answer to 4 decimal places of accuracy or something. Oh, yeah. Thank you. Negative. Yep. Okay, so then we can calculate that out using a calculator. So I got about negative 1.4457. So you guys got the same thing?